Hi guys, as I promised I would create a video on how to create an eveNG lab on Google Cloud with free Google credit. So let's get started. Before we begin, I just wanted to explain why I'm creating this video, because I don't normally really create videos like this. So a while ago we started meetups in the city of Riyadh in Saudi Arabia, because there were a lot of meetups but for cybersecurity, but mainly they were theoretical, so presentations and talks, but nothing practical. And there was a lot of need of different people who were saying on social media, like, what if we had like a meetup where we can exchange practical knowledge, where people with experience can share their knowledge, and where we can have hands-on meetups to really learn something, not just to go to a talk and come back and actually didn't learn anything new, but to really have some practical experience. So we did a poll with different people and we got a lot of response back. The experience range between students to people who have different years of experience, up to 16 years. And mostly they were network security engineers. And we also asked them what they wanted to learn out of these meetups. Most of them wanted to learn blue teaming and advanced troubleshooting. So both of them actually involve creating visibility, creating a lot of logging, and to have some common sense, some logical, analytic brain power. So we will mainly focus in these meetups on these two things, but there was also a request, or the third thing that was most requested was scripting and automation. So probably in a later stage we will also go deeper into that. But to do that we need a lab, and you can't just keep running virtual machines on your desktop, and different people have different specs on their PC, and we can't just provide hardware. And so we thought about doing that in the cloud, but then again we have some students and it's difficult as a student, as you know, to pay for cloud credits. So that's why we chose Google Cloud, and we chose to create a free trial version of Google Cloud. Well, it's the full version, but you get $300 of trial credits, and $300 will take you a long way if you use your resources smartly. So that's why we created eveNG on Google Cloud. The reason why we're making this video is because some people couldn't join our meetups because of them working in shifts. For example, employees that work in SOCs. So most of the people were 9 to 5, but some people had shifts working in SOCs. So it was difficult for us to find an appropriate time to where everybody is available. So this is why we are recording this video. It was upon their request, and also some other people who are from other cities that couldn't join us also requested to make this video. The lab is not only for these specific use cases, but you can use it for anything you want to learn. It doesn't matter if you want to learn systems. For example, you want to install some Linux machines, Nginx, host a web server, do some reverse proxying, whatever. Or Windows, you want to install Windows Server, you want to play with PowerShell, you want to play with Active Directory, and so on. Or you want to go more to the networking side, you want to play with routers, switches, and so on. Or network security, different vendors of firewalls, application firewalls, load balancers, and so on. But you can also use it, as we said, one of the use cases is blue teaming. And also for red teaming, the exact opposite. How can we test our network if it is detecting, for example, advanced persistent threats, if it is specific attacks, malware, and so on. You can also add vulnerable machines and have a Kali Linux machine and do some capture the flags, or pen testing, because a lot of people they test, or they install some vulnerable Linux and they do some capture the flag, which is mostly a Linux box with a local firewall. But if they go to real environment, suddenly there's a Palo Alto and there's a Fortinet and so on. It is much more difficult, of course. So to be able to test different techniques to bypass these firewalls, or to develop your own techniques or whatever, it is interesting to have these machines running. So this can be used for a lot of different things, but it can also be used for scenarios where you have a production environment, everything is working perfectly, you want to test a change, but you're not sure what the impact would be. You could have the same environment running in this lab, and then you can do your test. You can import the configurations and do your test there. So to see what the impact would be, or just you could have like a replication of a production environment in your lab as a test environment, to just play with a lot of different things to look at how you can configure or learn the environment better without actually starting to cause trouble in the production environment. So that was kind of the introduction. As I said, this is for the people who couldn't join. We had different people who excused because they work in a SOC, they have shifts, and other people have 9 to 5. So it's difficult to find a suitable time for everybody. Another thing was there was different people who wanted to join, but they're from other cities, other countries. So yeah, it was difficult for them to come to Riyadh to join these meetups. So let's get started with making the lab. First of all, we need to create a Google Cloud account. So as I said, you can get $300 for free. If you type in Google something like Google Cloud $300 trial, you will get this link, cloud.google.com/free, or in the blog post it will have the link. So if you click on it, I'm already registered, I did that, but you just fill in your information, you give it your credit card, and then you will get, or you come to the console or the dashboard for Google Cloud, where you find all the features of Google Cloud. If you click here, you see that the free trial status, I got $300 of credit for 365 days. So for free. Here you have different options, but we will not go over them all. We will just go to the things that we need to create the lab, as that is our focus. Mainly we will use Compute Engine, and this is why I pinned it. So you can pin it like this, and then it will be up here instead of scrolling down and searching for it. It's kind of annoying. To get started with our cloud environment, we will have to execute some commands. You will find them in the blog post that we will post in the description. And I have some commands here because these are very long and it's easier to copy paste, but most of them I will try to type so that it will not be too fast and it's not just copy paste and you don't see anything happening. So, but these are a little bit longer and are prone to have typos in them. So to get started, we first have to open our Cloud Shell. So the Cloud Shell is actually a Linux terminal of a Linux machine that you get for free from Google to do administrative tasks and to execute commands, but it's a general normal Linux machine. So if I do like commands, Linux commands, you will see that I can easily do simple Linux commands. So it explains as well what it is and how much space you have and so on. So as I said, we will have to execute this command. What this command does is, gcloud is like the commands to do things on the Google Cloud. You can also download it on your machine, so you can execute commands against Google Cloud and automate things. So we'll create a compute image, create with this name, so in this case Ignite, but let's call it, for example, lab.
and we'll use the source image project Ubuntu OS Cloud and the source image family Ubuntu 16.04. Okay, and then this is the most important thing: to activate the nested virtualization, we will use this API call, this one, to activate it. So if we go back, we copy paste this command, and we do it in the shell here, and then we do enter. So if you never did a command in the Google Cloud Platform, your APIs will not be enabled. It's not enabled by default. So it could be that it will ask you to activate the APIs. So if it asks that, before you had to go to a link, it showed a link and you had to go to that and then click enable API. But now I saw they changed it, so you can immediately ask from they will ask from the shell itself, do you want to activate it? And you can just say yes, and it will activate it automatically, which is much better. So now it's creating this image that we will use to create our machine. When we had the meetups, this is a step where a lot of participants had issues with, because they when they create the machine, they choose the wrong image. So I will emphasize on that, and when we create the machine, I will clearly explain it, that you have to create this image, because if you don't create this image, you can go through all the steps until almost at the end you will see that you did all that for nothing. You have to start all over again. So if you get this message that status is ready, this is a good sign. So you just created your image that we will need. So here you see name is lab. So if we go now to virtual machines, compute engine, VM instances, we'll see we don't have any machine yet, so I'll close this shell for now. So we click create. Here you will see it will ask us some information like the name and region and zone and so on. Let's just call it now lab 1. Okay. You also see here how much it will cost. This is a monthly estimate if you turn the machine full time, so all the time. But of course, if it's a lab, you will not keep it running all the time. It will mostly in the evenings and the weekends, so it will be much less. So here you see the hourly for 1 CPU and 4 GB of memory. You see it's only like 3 cents. And we can make it cheaper. I will show you later how to make it even cheaper. So now you have to select a region and zone. This is actually important because depending on the selection of your region and zone, it could be that some features are available and others are not. And some have premium features that are not available in another region. So for now we'll just skip it. We'll just go and select one that is straightforward for us. We will not emphasize on it. But if you're really using it in a project that is important, you can better investigate it. So I'm just giving that. To select the region and zone, Google has an interesting site called gcpping.com. And what it does is actually just tests the latency from the region or the place where you are. So in this case, you can select the region that has the best or the less latency, and you can select the region that is that has the best performance for yourself, because it's your lab in the end, or even for your customers if you have specific customers that you're working on another project. It will these results change, to be honest, because most of the time it gave me Belgium and Frankfurt as the best. Now it's London, so it depends. But you see that in my case, at this moment, I could better choose for London. I'll still go for Frankfurt, because I always host them in Frankfurt. So here you go, and that's it. So the zone, you can choose a zone if you want to. And here you have the machine type. For now, because we will just do some basic Linux commands, we will not run any virtual machines in our lab. we can just keep it low to avoid having huge costs. This is the most important thing here. This is why I said that a lot of people skip this step or make a mistake in this step. So the boot disk standard, it's 10 gigabyte of a standard persistent disk with a Debian 9 image. But we created our own image based on Ubuntu. So we have to change this. A lot of people skip this, so please change this, else you will do all the steps, in the end it will be for nothing because you didn't choose the right image. So we have to click change, and then you will see different images that Google offers, but we have to go to custom images because we created our own. And here you will see the lab image that I just created. So you see the time here, I just created this one. And then we have to change the size of the disk. So you have also SSD, but for a lab environment it doesn't really have to be SSD. You can just use a standard disk because of course SSD is more expensive. And to start, let's say we'll use 60 gigabyte of disk space. You can later make it bigger, but of course you can make it smaller. So, and depending on the size, of course, it will also cost you money. So let's select this. So you see now we have 60 gigabyte standard disk with the lab image. It's very important. So we have to allow HTTPS to access. You will be thinking, oh, HTTP, and this is cybersecurity, Meetup, and so on. Well, we gave the choice to the participants if we later want to change it to HTTPS, but for now we're going to install it with HTTP because HTTPS of course needs additional steps, but it is possible. And you can use you can do it in different ways. You can have like another machine that is your reverse proxy that has a certificate, or you can have generate a certificate with Let's Encrypt and use that. So open this in the firewall, else you can surf to the machine. And for this we don't have to change anything, but I'll just explain some small things that could be beneficial as like extra knowledge. So nothing here. Here you will see the disk, delete boot disk when instance is deleted. So if you just sometimes spin up disks and you want to remove them, what happens is if you have this enabled, it will also delete the disk. But if it's disabled, then it will leave the disk. So at a certain moment you spin up machines, you will remove them, but the disk will be there taking space and you're paying for that. So if you're on a budget, not interesting. So just leave this checked so that it will also delete the disk when you delete the machine. So here in networking you have some different options. You will see that our internal network in the cloud is 10.156/20. This is interesting if you work with reverse proxies and you have your internal machines talking to each other and so on, that you know that. And here for your external IP you can choose. You can either have none. You will be asking why would I do that. Again, if you have, for example, reverse proxy, you have machines that are behind that reverse proxy, you don't want to by mistake start a machine and automatically it gives it a public IP, because standard, as you see, it is automatically. So this is when you get a machine automatically. So the moment you start the machine, it will get a public IP from the pool of Google, and it will give it to your machine. So you want to avoid that if you don't want that machine to be exposed directly to the internet. So that's a small gotcha. Or you can create your own public IP that is fixed. Why would you do that? Again, as we said, if we want to do HTTPS and we link it to a domain name, we want to have a fixed IP that stays for that machine. Even if we're not running it, our DNS still points to that public IP, so the moment we run it, it will be accessible by domain name. Also, for example, as I said, again, the example of a reverse proxy, you can give it a fixed IP, and then all your different lab environments or testing machines and so on can be behind this public IP of the reverse proxy, and that's it. So you have different tiers, you could check it up if you want, but for now we'll just leave it standard automatically because it's a lab. We're not going to have a fixed IP unless, as I said, we go HTTPS, or sometimes it's also interesting when you have a real hardware environment or local at home or at work or whatever, and you want to connect it with some machines in the other environment. Then of course when you do some configuration and so on, you want to have the configuration fixed and you don't want to change it every time. So this is also a possibility. Just to show you something else, if you go back to management, here you have something interesting. It's called preemptibility. So it says Preemptibility VM costs much less, but lasts only 24 hours. It can be terminated sooner due to system demands. So what this does is you can run a VM at a huge discount. I think it's 60% or 80% discount, but there's a big but. It can only last for a maximum of 24 hours. It shouldn't be an issue if you just run a lab, because in the end you will go to sleep and you will shut down the machine. But, another but, Google can also terminate it sooner. So it could be that you just started your lab, half an hour later Google says, oh, I need these resources, I'll reclaim them, and they'll shut down your machine without any notice. So if you really want to go cheap, and you don't care that suddenly Google stops your machines because it's just a lab that you don't care about and you're just playing in and so on, you could put this on. So if we compare, now we have this machine costs 4 cents. If we put this on, suddenly, look at that. Big difference. So monthly, it's now $11, almost $12. And while if it's off, it is monthly about 34. So it's about a third of the price. So it's very interesting for people who really want to go cheap. But in our case, we're not going to do that. Let's create the machine. So what it does now is just create a virtual machine with the image we gave it, with the specs we gave it, and it's starting now. So most of the things I will put in the blog post, so you don't have to wind back and listen to me repeating that. So if you just want to follow the blog, you can do that. But this is like something to help you with the if you get stuck or something, or you want to see how it's done. So if we refresh it, you see I get a public IP. As I said, this is a public IP we get automatically. This is an internal IP. Remember the /20 range. You see West 3 Frankfurt, our name. You see that it's running here. Instance is running. So here you can go. You can SSH to it. So you have a pop-up console, SSH pop-up console that can bring you to the machine. That's what we're doing now. And let's do some configurations on the machine that we just created. So first of all, let's go and change yourself to root. So sudo su. So let's change the password. Okay, so we changed the password as the first step. Now we will have to add a entry in the host file. So let's use nano, as this is the easiest editor. We tried the VI in the meetup, but it didn't work out that well. So here you will see localhost. We will add one that is similar, but it's instead of 001, it's 011. So most people think that localhost is only 127.0.0.1, but actually it's a /8, so 127 whatever. After that is all localhost. So here we will add eveNG .example.com and then eveNG. Okay. Then to save it and exit, so you first do Control O as written below. So the small, we call it a Chinese hat sign below for every command, it's Control. So right out, it has the small sign with the O, so it's Control O, and then it says the file name. So you just want to overwrite it, so you keep the name and just press enter. So it says wrote 14 lines, and now we want to exit. Control X. So we change the host file, and now we want to change some settings in the SSH config file. So let's go to the folder, or you can just copy paste it from the blog post. That's maybe easier because in the meetups we had different people going to the wrong files. It's also a tip, in Linux if you press tab it auto-completes, so the moment you have enough characters that it's unique and you press tab it will auto-complete. Use that, it's faster, but also it saves you from making a lot of typos and then starting to make new documents and editing non-existing documents or the wrong documents or files. So this is the file we will edit. Now we have to look for a specific configuration, that is permit root login. Here you will see it under authentication. You will see prohibit password, and this we will change to permit root login. We will say yes instead of prohibit password, and then we have another change that we want to do. So what this does is, as the configuration settings says it, permit the root to log in. So in this case we will be able to SSH in the machine with root that we will need later for different configurations. So what we also have to change is password authentication. Put it to yes, because we will log in with our password. So the same with nano, you do Control O, enter, Control X, and if you use another editor you just save the file. And now we will restart the service so that these settings will be activated. Okay, so let's try now to open a SSH connection to the server, not from the console but from a terminal. So in the meetups I explained how PuTTY works, because a lot of people use Windows instead of Linux. So if you have Mac, it's the same as what you see here. If you have Windows, you can use PuTTY or any other SSH client. The thing is, you just have to SSH with root to your public IP that you find here. So you just copy paste your public IP here, and then you SSH to it with root. Okay, so if I do that, normally, so you will get a fingerprint. It's normal because a lot of people or not used to SSH asked me, oh, I get this error, is it okay? So yes, you can just press yes. And to be honest, because these are cybersecurity meetups, in the future we'll probably go deeper into that, but this is actually like a fingerprint of your server. So if you connect to a server and you know the, let's say, the ID of this server, you can check it by checking this SHA-256 hash and confirm that this is the same size, to avoid that you connecting to the wrong server or have a man in the middle attack or whatever. So now I give in the password and I'm in with root. So this is a sign that the configuration that we did and the SSH config file is okay and that it works. So what we now have to do is look at the interfaces, because eveNG expects the interface to be ETH0. So, but Google gives us something else, as you can see. If we do ifconfig, it's like the ipconfig in Windows, you will see that we have the loopback interface here. It's not important now, but then we have our second interface that has the internal IP 02, as you see here, as internal IP. So this is our interface, but it's not called ETH0, it's called ENS4. So we have to change that to ETH0. So we'll again use nano to go and edit the file. So we go to etc udev rules and then 70 persistent net rules. If we enter, you will see at the end that this is the name of the interface, and this is persistent. So every time it reboots, it will use this name. So we change it to ETH0, simple as that. Again, Control O to exit, Control O to save. You see the name, enter, Control X to exit. So little by little you will get used to working with the text editors in Linux. It is important. So later we will probably switch to another text editor if the participants are comfortable with Nano, just to learn different editors, as it is important to be able to edit your files on any machine. Okay, so now we will reboot the machine so that we will get the machine up and running with the new interface. So your connection will be closed and you will have to wait a little bit before you want to retry again to SSH, because it takes some time for the machine to reboot and then for the SSH daemon to be up and running. But ideally, if everything worked correctly, we will be able to have the interface with the name of ETH0. If that is not the case, you did something wrong and you have to redo the previous step. So let's see if it's up and running. Yes. Okay, we're in. If we do ifconfig, we expect ETH0 and this is correct. So this is what eveNG wants as its interface. So let's continue now. What we're going to do now is actually install the eveNG. So eveNG made it easy for us by providing us with a simple script. So we get is to get a file from the internet. This is a bash script, and then you execute it with bash. So this is a pipe sign that connects different commands. In the future we will go over piping and bash scripts and so on. So we enter and then it starts downloading a lot of things. Normally the internet from the cloud is very fast, but it does take some time to get everything up and running. We normally don't expect anything to be skipped. It should install everything, but to be sure you can always look at the screen to see what's happening, to be sure that you don't get any big errors or it's not interrupted or something. So we're back, everything is installed. Everything went fine. So now we're going to reboot the machine. Again, let's wait a little bit for the machine to reboot and then try again to log in. So if you get connection refused, it's a sign that the machine was not fully rebooted yet, so it could be that the SSH daemon is not running yet. So you should try again. So now it's good. So when you reboot, you get this login screen. So you give in your root password 2 times. I'll leave the host name as it is. I'll leave everything as it is. Just go through it. Okay. Of course, unless you do use a proxy or whatever, but in our case, it's not the case. So try to log in again. So after we finished that, the machine was rebooted and we have access again to our machine. Now we'll go through some different steps, but first let's go and do a update to update our machine with the latest updates. So I would love to reboot now to then restart the machine, and when it restarts we can go to our machine here, refresh it to be sure that we have the latest public IP, and then when it restarts we should be able to go to the machine. That's the thing, if you open a firewall on HTTPS as well, it will automatically choose HTTPS over HTTP. So HTTPS of course is not configured yet. So we type in the username, standard it's admin, and defaulted the password is Eve. And here you can choose native or HTML5 console. Remember when I showed you the lab, I just clicked on a machine and it opened a pop-up with guacamole. So it gives you like a console window within the browser. This is when you use HTML5 console. You could go native console, and then when you click on a machine, for example, that uses Telnet, it will automatically connect it to PuTTY and open it in PuTTY on your local machine. But the thing there is you have to open different ports on the firewall, and it's not that practical. So I prefer the HTML5 console. So when we log in with admin and the password of Eve, so first of all let's change the password because it's kind of easy now. 3 and then let's say okay. So I changed the password. That's it. Let's just check it. Admin and then sign in again. Perfect, it works. So what I want to show you is something here, because we're not finished yet. System status. I will see something here. KSM, and before when it was still loading you saw UKSM, right? So KSM is off and UKSM disappeared. These things are very interesting because they help you, they help the performance of eveNG by reusing pieces of software and not running them different times. So if you need something, for example, you run different routers, 20 routers for example, with the same image, it will decompress or compress the images so that you don't run the same image 20 times but only once, and it's referenced to that. So this is very important to activate it, and that's what we're going to do now. But for to do that, we have to change some settings. So let's log into a machine again. Okay, so when we look at the kernel we're running, we see that this is it, 415 GCP. So we'll have to change it to the one that eveNG copied when we did the install script. If you were following, you will see that at a certain moment it downloaded some. So we will find it in the boot folder. If we do an ls here, you see you have the 4.15 and then you have a 4.9 eveNG. Okay, so you see here UKMS. Remember when we showed it in the browser, when I said the setting that helps you in performance? So this is very important. So to fix that, we want to move these kernels so that only this kernel is used. And a small gotcha is sometimes when you do updates, it could download a new kernel, and then again it will not use it will use the other kernel and it could cause problems. So try to keep that in mind, and try to, if you have some issues, try to run this command to be sure what kernel you are running. So let's make a directory, and let's call it backup configurations. Okay. So and then we want to move all the I think they all end in GCP 1029, so that's 1029 GCP. So what we do is we're going to move all the kernels that are not the one of Eve, and so all of them end with 1029 GCP. So all of the file, this file, config, the initRD, the system map, VM Linux. So we will move them, and V is move. Asterisk is any character, so we will match anything that ends with 1029 GCP. I will move all these files to the folder we just created. Excuse me. Backup CFG. So if we do that, normally, if we do ls now, you see only the eveNG ones are left, and you'll see that in this folder we will have the GCP ones. It's within the folder backup CFG. So now we're good to execute the next command that you will also find in the blog. So we'll have to change the grub. Where is the document? So you just paste it here, enter, and should be okay. But very important, you will have to run the next command, because else you will break your machine. You can fix it. So one of the ways I could fix it, for example, is to take a snapshot or to mount this image or this disk to another instance that you make, and then you edit the files, or you put back these files, the original files that we moved to backup CFG. We put them back, and then we can start the original machine back, and so on. but just try to avoid it. Okay, so this command is very important to execute it as well, because else you will be in trouble. We do that. So you see, it found the images, it installed them, looking good. Let's do a reboot and check if it worked. So let's try to log in again. If the machine is back. Seems to take its time. So now when we execute the same command, you see now, interesting, we have the eveNG kernel. While here we had the GCP kernel. So that's good. Now let's go back to the let's log in again and see if it also activated the setting that we looked at. So if we go to system status, you see here it's still UKS status. Here you go. UKSM status on, everything looks perfect. So this is what we needed. So actually now we're done. You can now run machines and add machines in your eveNG. So if you want to learn about eveNG, there's a lot of tutorials online, videos online and so on. The reason why I made this video is because there is no complete tutorial. I didn't find any complete tutorial that does everything I did in the meetups to get the lab up and running. Because in the next step we will add connection to the internet and so on. You have bits and pieces and some blog posts and videos, but I didn't find it completely. So this is why I made this video. But to learn eveNG, there are different resources, blog posts, and on the side of eveNG itself, eveNG has a nice channel with different videos that explain a lot of things. But just to go over some basic things, you see here the menu management, system status where we are now, information, and that's it, right? So if we go to the main menu again, here you have where your labs are. So if we create a new lab, we can give it a name, test 1 for example, version, author, whatever. We save it. So now it will open this test 1 topology. Okay, so this is the same as we showed you before, the same as this one, same as this one, but here we added already some devices, some things. So this one is empty, but to add a node you just right click or click here, add a node. Okay, you click on it and you can select from all the devices that you have. At the moment everything is gray except virtual PC. Virtual PC is like a fake PC that does some basic commands like ping and so on. But the rest is nothing. If I go to my other lab, I click node, you will see I have Cisco ASA, CSR, and so on. And if you click on one, for example, if I go and type Linux, okay, so I have Kali, I have Debian, CentOS, TinyCore, and so on. So you can add different amounts of nodes at once. You can change the icon, give it CPU and RAM you want, change the settings, and so on. But this is how you add a node. And then if you want to connect them to each other, if you go over a device, if it's shut down, because if they're started you can't do that, but if it's shut down you can just drag and drop to a device and then select the interface that you want to use. It's as simple as that. So back to original one. So you see different menus here that are very straightforward. And then you can either lock the lab so you don't accidentally change things. For example, if I go back to this lab as a demo, I can move this one, right? So sometimes you put everything in order, very nice, and suddenly you wipe it all and you can't go back. So in that case, if you have your lab, lab up and running, you could just lock the lab. What I did was close the lab by accident, so it's next to each other. What I want to do was lock the lab, and now I can't, you see, even by accident I can't do anything. So everything is locked down, so it's perfect when you have your lab up and running perfectly and you don't want to mess it up, you just lock it. So these are basic commands, but as I said, to get more information on eveNG, there's a lot of resources. So this is the lab, but we're not finished. What we did in the meetup as well was to give it internet connectivity. So we wanted devices to have internet connectivity from the devices to the internet, because some devices may want to have internet connectivity to get updates, to just surf to a specific website or download some files, whatever. You will need, it's interesting to have internet within your lab. And as you also see in this topology, you see that we have some things that are doing tests from the internet, going to your edge routers, going to your edge firewall, and so on. So to do that, we will have to do some other commands.
Excuse me, I got distracted. So what we did now is we installed the we completed the installation of eveNG on the Google Cloud instance, and now we can actually add images or appliances that we want to add without any issues. So everything should work perfectly. And to do that, there's a lot of tutorials on the website of eveNG, how to get how to eveNG. So here you go. You have a whole website with different links to tutorials on how to create different images. So you have a lot of Cisco devices, Checkpoint, F5, Citrix, Juniper, different devices, Palo Alto, my favorite, Fortinet, and so on. So everything is here. You can even add VMware ESXi and vCenter and Windows clients and Windows servers. So in our case, let's just go to Linux machines, because we just want something quick to show you how to add images, and these images are already prepped. So eveNG has some Linux images that are already prepped. If you click this link, you will come to a mega share where you have different operating systems or different Linux distributions. So in my case, I will just download TinyCore. I already did that to save time. And now we will SCP it to the machine and put it in the right place following this tutorial, and then we will add the machine to show you how it works. So let us first do this. Put this one here. So as I said, I just downloaded the same zip that was here, and then what we will do now is we will SCP it to the machine. So first, let us just take the IP. Yeah, that's normal. Okay. So SCP. Just for the people who don't have Linux or Mac, Mac it will work the same, but for people who use Windows, you can use WinSCP. So there is an application called WinSCP. It does the same, but it's just an executable, and it works just the same way as a FTP client like FileZilla or whatever works. So it's very easy. You just connect, you give in the IP, username, password, and then you see the folders on the website, on your remote host and on your local host, and then you just drag and drop, and everything will magically appear. So we will SCP this to our server. So root at okay. So we'll just put it immediately in its place. So if you're root, you can easily copy it to the right directory. If you're not, you can best copy it to your temp folder. But then if you reboot, you lose it. So immediately after you put it in your temp folder, move it to some other folder to avoid to have it persistent after reboot. So I want to SCP this file. So I give it 1, 2, 3. So it's uploading now. In the meantime, let's go back here and look at the other images. Or in the meantime, even better, let's continue our configuration. So while this image is uploading, so we can do some tests with it later, let us configure the internet connectivity. So what we had in our lab was different devices, or what we're going to create in our labs and the meetups will be different devices, and some of them will have to connect to the internet, for example, to connect to some cloud licensing server, or to get some updates, or just maybe you want to download you want to connect a GitHub to download a script or whatever. So these things are needed if you really want to take your lab seriously, and that's why we created or we will configure the lab to be able to connect to the internet. And to do that, we will configure now the external interface, or the interface that has internet connectivity, to be able to accept connections and forward it to the internet, NAT them, and then get the response back, so that different devices can use the same interface. So we'll first do the change or the configuration for the people who just want to do it for temporary or a temporary period. So for example, if you just want to temporarily give it internet connectivity, you can easily add in 3 commands and done. You can give it an IP and you can connect to the internet. But in our case, we will configure it persistently, because we will have this cloud as internet available for every time we run the lab. So we don't need to reconfigure every time we reboot, especially because our lab, we won't use it all the time. It's interesting to have it persistent. So now first, for the way to do it not persistently, let us connect. Okay, so first of all, we're going to give let me show you something. If we do ifconfig, we see all the interfaces that eveNG created. So before, remember, we changed the name of the interface to ETH0, and we had a loopback interface, that's it. But now you see all these PNet interfaces. So PNet 0, you see it has the internal IP address that we saw in the console of Google. PNet 0 is the one that connects to the internet, right? And the rest are all cloud interfaces. So if we go to our eveNG, we add a network. You see here we have cloud 1, 0 is management, cloud 1 up to 9, right? So what we want to do is make one of these clouds a real cloud that connects to the internet. So in this case, we will use PNet 9, so that will be cloud 9. So first, we will have to give it an IP address that will be the gateway for this connectivity. So IP address, so you can give it whatever IP address you want, but just be sure to, when you copy the commands from the blog post or the article,
that you copy paste them all together and change the IP, do a search and replace and change the IP, because it can give you issues in the future or in the next steps, because we will add the same range in different locations. So for the interface, for the DHCP configuration, and so on. This is very important that you don't mess it up, because then you will get issues and you will have you could have a hard time troubleshooting it. So in our case, I used a IP range that is not private nor public. It is private, but it's like experimental, because it's just a lab environment, and I didn't want it to block our uses of other private ranges in the future if we want to do specific labs, or maybe we will mimic a network of one of the attendees or something. So this range we will not get in trouble with any other range that we can use from the private ranges. So this is what I preferred, because now you configure it and you have your lab and you have it running for a couple of months, and suddenly you have this idea that I'm making a new lab, and you give it a range. For example, what if I used 192.168.10/24, and then now I remember, but in a couple of months I don't remember, and suddenly I use the same range and I get into conflict and so on. So in this case, it will not happen. That's why we use this range, but you can use any range you want. Also, we use here PNet 9 to be Cloud 9. If you have some reason to use another cloud 5 or whatever, you can just change it, but again, you have to change it over the whole configuration. So to make it easy, just use the same settings as because it doesn't really matter if you use Cloud 9 or Cloud 5. So now we configured the IP address for PNet 9. So if we do config PNet 9, you will see that suddenly, while here we didn't have an IP, suddenly we have this IP. Okay, so that's a good thing. And then we go further, because our machine should be routing, should be able to do it. We will actually configure our Linux box a little bit as a router, so it has to do IP forwarding. And so we will do that by executing the following command. Okay. Okay, PV4. And then IP forward. Okay, so that should be done as well. And what we do now is we have to do, so remember I said we will send it to the interface that is connected to the internet, and we will do nothing on it. So that's what we will do now with IP tables. So we will NOT it. We will NOT it and post routing, so after the packet is leaving, and then the interface is where the out interface is PNet 0. Remember that is the interface that is connected to the internet. Okay, and our range that we chose was 198.18.18.0/24 and masquerade. If you want to know any of these settings and you want to dive deeper, you can always Google them. Shouldn't be difficult to look it up. So now this is the configuration to do it non-persistently. So after reboot, the settings will disappear. As I said, it could be that you just need it for a specific time period, this internet cloud, and you just copy paste these 3 commands. It takes 1 second because you will have it in the blog, and you just copy paste these 3 commands and you're done. So what we'll do now is to make it persistent. So first of all, we will make the IP tables entry persistent, and because we just entered this one, we will just save it to be persistent. If you didn't do this now, you will have to enter it now and to be able to do the following commands. Okay, so we will save it now by doing the following commands. Okay, Okay, and now we will have to edit the RC local file. Okay, and here you see that it has exit 0. We will have to add the following command above exit 0. So be sure to do that above exit 0. Okay. So it's actually just, as you can read, restoring the IP tables config that we just saved. Simple as that. So if it reboots, then it will keep it. Okay, so now IP forwarding, we'll make it persistent as well. So we'll see that it's not that difficult to change that. So as it says, uncomment the next line to enable packet forwarding for IPv4. Help, we remove this small sign that was here. We save it. And now our Linux box became a sort of a router. Okay, but we are not done yet. We have to execute the following command. Okay. Perfect. So as you see, now it says IPv4 IP forwarding is 1. It is a good thing. Okay. Now, of course, now I put in sudo, but I'm already root, so but it's just to out of habit, I guess. Normally, it's not best practice to do or work on the root, but this is just a temporary lab to do this tutorial, and then I will delete it. So okay, so last thing that we have to do is change the interface that we interface of our Cloud9, which is PNet9. Network interfaces. Okay. It's at the bottom. You can just go here and put it on static, and then we give it the address that it needs. Again, all these locations where you put the IPs, if you chose something else, please be aware that you have to give in the range you selected. That is okay. The rest I will just leave. So now everything should be persistent at least. Let us finish. So normally the upload is done. Perfect. Now we can actually immediately check it. So yeah. Look at that. So our Linux zip file was uploaded. So let us just follow the instructions how they said it. So we can just, of course here they used Linux Ubuntu, but the same commands. We and of course also eveNG expects you to use your common sense, not just copy paste these tutorials. So that's it. Look at that, it extracted it. It's already created a folder and added the image or the disks. Now, as we still have the zip as it is described in the manual, we will immediately delete that unless you want it as a backup in case you screwed something up, but it will take this space.
So that's it. Now we just have to fix the permissions. Every time you add an image, you execute this command. You will see that in all the how-tos to fix the permissions. That's it. So normally now we should be able to add Linux as a node. Look at that. We have the tiny core 6.4, as you see here, tiny core 6.4. So if you have different Linux images, as I showed you before, you will have all the versions here. So you add a Linux node, but you can select the version. The same with Windows. If you have Windows Server 2012, 2016, 2019, you just select the version. You can change the resources and so on. So if we add a machine here, okay, and we add a cloud 9 here, what should happen? Normally nothing. Why? Because now we first have to give it a fixed IP. We have to give it a fixed IP within the range that we configured above. So the 198.18.18, which we didn't do. So to make it easy, in our lab, we decided to have a DHCP server running on this Cloud9, on that interface PNet9. So when we add devices, they will automatically get a DHCP, they automatically get the DHCP address. So let us now just reload, because we made the settings persistent and we want to check if they will stay. Sorry, reload. Been on some Cisco devices today that needed reloading while we configured them, so got kind of stuck there. Okay, so now it's rebooting. Let's wait until the instance is back. So what we will first do when we finish the reboot is check the settings that we made persistent by simple commands to be sure, and then if that's okay, we will install a DHCP server and configure it to be able to give IP addresses dynamically to the devices that are configured to get a DHCP address, but also leave a range for static devices like your router and firewall and so on that you want to configure with a static address. But DHCP is very interesting, especially if you have different client machines and you just want to update them or download something. You just connect it to PNet9 and automatically it has internet connectivity. So let us check now if our settings are persistent as I myself have claimed. Let's hope they are, else we will have to troubleshoot why they are not. Forwarding. So this is one, great. So IP forward is enabled. Second thing, let's look at the IP tables, and if they're nothing as expected, look at that. Perfect. Masquerade, source from this range, destination, the internet, anywhere. That's also perfect. And now let's look at PNet9. Look at that. So now we'll install the DHCP server and configure it that this .1 is the gateway. When traffic comes there, it will not head outside to the internet, and that's it. So to install a DHCP server, you can, if you have like experience with a DHCP server, you can install whatever you want. But in our case, we will install ISC DHCP server. Okay. Perfect. Now let us go to the config file. I'll just directly edit it from this location instead of going to it. ISC, yes. It is. So here you change this interface to pnet 9. This is the interface that we will use for DHCP. So as you read in the comments, on what interface should the DHCP server serve DHCP requests? So as you know, our cloud 9 is this one, and this one will receive DHCP requests. So we have to configure pnet 9. I'm giving a little bit more information to explain that. I'll try not too much, but if you know how Linux works and you know these commands, it's better just to follow the article, the blog post, and it's much faster. And you don't have to hear me talk about things like this. DHCP config. So now we will edit the DHCP config. First of all, of course, none doesn't exist yet. Not on my machine, at least. So first of all, we will have to make this DHCP server authoritative because we don't have any other. And then let us add the DHCP configuration, but I will not type it, as you see, because I'm working with two different keyboard layouts lately. I tend to make a lot of typos. So let us just configure. No, we passed that stage. Yeah. So we have this range with the subnet mask. We defined here for the DHCP between 50 to 230. So I can use a lot of IP addresses under 50. Of course, not one because it's our gateway, but from 2 up to 49, I can easily use as fixed IPs or static IP configurations for my router, firewall, and so on. And if I connect something to the cloud that uses DHCP, it will serve it one of these IPs. So given whatever DNS server and so on, you can change the lease time if you want to. Most important thing is that define the range if you want it to be smaller or bigger, and the interface if you changed it before. And for the rest, here's the router. That's it. So now this is the configuration for DHCP. Now just let's start it. System start. Let's see DHCP server. HTML enable. Okay, looks good. Let us just quickly check if everything is up and running as it should be. Active running, looks good. So now let's start this tiny core Linux machine and see what happens. Oh yeah, I will have to refresh again because we did a reboot. Okay, it's up and running. So, as you see, this is a great small machine that you can use to do some basic tests. I like it more than the VPS, because the VPS, I saw it sometimes doesn't give me the results that I want. So look at that. We have the first IP in the range. Let us try to ping Cloudflare's DNS. Look at that, the response. And let us go to Google. Amazing. So now we have internet persistently configured on this machine. We added a Linux box to play with, but in the same way you can add a lot of different images, and that's it. So for the people who asked to make this video, I hope you enjoyed it. If you have questions, please reach out to me via the email that was sent to you initially. And for the rest, the people or the participants of the meetups know that we have a Slack, and you can just hit me up in the Slack and send me a private message or discuss it in one of the channels that are in the Slack. For people who don't know me but are stuck or have a question, you can find me on Twitter. I think that's the best way to reach me, Twitter. So it's at AbderEM on Twitter. This is my Twitter account. So you just have to DM me and on Twitter, and we'll see what we can do or how we can help. That's it. If you are interested to receive more videos, so I didn't expect to record videos, because as you have probably noticed, I'm not really good at that, and I don't have the time to edit videos and so on. But if you enjoyed it and you want to have more of these videos, leave a comment or send me a private message on Twitter saying that you want to have more of these videos, and I will try to make more of these videos. But the main focus was to have real life meetups, practical meetups with the participants. That's it. Thank you very much. Bye.